So another problem I saw people struggling with is something that looks like this. All right. So on last week's work, it wasn't necessarily looking like this. It had a lot of variables, and there's a reason behind that. Normally, problems like this, I'll just give you a side, a couple of angles, and tell you to solve for a missing side. The way you do that is by pretending you need to solve for everything. Here's y, here's z, here's w, and it helps for you to just find everything and then eventually tell me, oh, I know what x is equal to. So I'm going to demonstrate this problem on paper in a bit, but this is how we initially set this up. Now, if you recognize on this side here, this is one triangle. We'll try to solve for this one first because we have enough information. We have a side and an angle. And then once we do that, we'll have enough information to solve for this one over here. In order to solve this problem, I'll obviously need my calculator and I'll tackle it one step at a time. Oops, there we go. Okay. So my initial step will be to solve for y variable down there. Okay. I know this is 55 degrees, so I'm going to label the first triangle, the left one, based on that 55 degrees. So this will be opposite, this will be adjacent, and this will be hypotenuse. Okay. Now, in order to solve for y, I need to take the hypotenuse and adjacent. So based on so, ka, toa, what combines a hypotenuse and adjacent would be cosine. So cosine of 55 degrees equals adjacent y over hypotenuse 16. All right, cosine of 55 according to my calculator, cosine of 55 is 0.574 if I round it. So 0.574 equals y over 16. Put this over 1, cross multiply, and I get 9.18. So y equals 9.18. Okay, so this is y, 9.18. Now I could either use Pythagorean theorem or trig to solve for this z variable here. I'm going to continue to use trig. So I know the opposite. I'm trying to solve for opposite. I know the hypotenuse. So opposite and hypotenuse, sine. So sine of 55 degrees equals opposite z over hypotenuse 16. Okay. Once again, I go to my calculator. Sine of 55 is 0.819. So 0.819 equals z over 16. Put this over 1, cross multiply, and you get that z equals 13.11 if you round. So 13.11. All right, so that takes care of this triangle, this half. Now I need to worry about the other half. Okay, so we know that this is 40 degrees and we're going to label everything based on that 40 degrees. Okay, so this side is opposite, not because I pre-labeled it, but because 40 degrees is opposite to this side is adjacent, and this side is the hypotenuse. Okay, so once again, we're going to solve it using that information. All right, now let's solve for adjacent. Okay, we know the opposite side. We want to solve for adjacent. That is toa. So tangent of 40 degrees equals opposite 13.11 over adjacent x. So put this over 1, right? So I'm going to solve for tangent of 40 on my calculator. Okay, and I get 0.839, rounded to the nearest decimal place. So 0.839 over 1 equals 13.11 over x. Next, I cross multiply like this. I get 0.839 x equals 13.11. Now I want to solve for x, so I divide both sides by 0.839. All right, of course I plug that into my calculator. So 13.11 divided by 0.839, and I get 15.63 rounded to the second decimal place. So 15.63. So x is 15, sorry, not 16, 15.63. Right. Now that I have those two sides, the last side, the hypotenuse, I'm going to solve with Pythagorean theorem, just to show you that I can use it. A squared plus b squared equals c squared. C squared is always the hypotenuse, which is that one. So 13.11 squared plus 15.63 squared equals c squared. All right. Plug that information in my calculator because that's why they're invented, so we can use them. And 63 squared, okay? And I get that this side combined is 416.169 equals c squared. I want to get rid of the square, so I take the square root of both sides. Square root of 416.169, and I get that the answer of 20.4 equals c. Okay, that's my hypotenuse, 20.4. So all the answers in the end. Okay, so x equals 15.63, y equals 9.18, z equals 13.11, and w equals 20.4.